Risk management with inspection activities, ensuring safety and compliance through thorough inspections. Introduction to risk management with inspection activities, overview of risk-based risk management. Risk management with inspection activities is a structured approach used to ensure the safe, reliable, and cost-effective operation of pressure equipment and industrial assets. This approach is commonly aligned with risk-based inspection, RBI, principles, where decisions are driven by an understanding of both the probability of failure, POF, and the consequence of failure, COF. Rather than relying on fixed inspection intervals or purely prescriptive rules, RBI-based risk management prioritizes resources toward equipment that presents the highest risk to people, the environment, and business continuity. Inspection plays a critical role by reducing uncertainty in equipment condition, which directly improves the accuracy of risk estimates. However, inspection alone does not prevent failures. It enables informed decision-making so that appropriate mitigation actions can be planned and executed. This topic introduces the overall concept of integrating inspection activities into a broader risk management framework, emphasizing alignment with industry standards and best practices. It also highlights the importance of viewing inspection as one element within a comprehensive integrity management system that includes operations, maintenance, engineering, and management commitment. Risk management process, from risk ranking to risk mitigation. The risk management process begins after an acceptable risk threshold has been defined and a formal risk assessment and ranking have been completed. Equipment items are evaluated based on their likelihood of failure and the severity of consequences should a failure occur. Risks that fall within acceptable limits may require no immediate action other than routine monitoring and reassessment during future RBI cycles. In contrast, risks deemed unacceptable must be addressed through deliberate mitigation strategies. This structured process ensures that decisions are consistent, transparent, and aligned with organizational risk tolerance. By clearly distinguishing between acceptable and unacceptable risk, owner-operators can focus effort and resources where they provide the greatest benefit. The process also reinforces that risk management is dynamic. Changes in operating conditions, inspection findings, or equipment performance may shift risk rankings over time, requiring reassessment and updated mitigation actions. Risk mitigation strategies, key options for reducing risk. When unacceptable risk is identified, several mitigation strategies can be considered. Decommissioning may be appropriate when equipment is no longer essential to operations. Inspection can be used to improve understanding of equipment condition and reduce uncertainty, potentially lowering calculated risk to an acceptable level. Repair or replacement decisions involve evaluating cost, remaining life, and operational impact. Additional mitigation options focus on reducing consequences of failure, such as installing isolation systems or detection devices, or reducing probability of failure through material upgrades, design changes, or operational adjustments. Effective risk management often involves a combination of these strategies rather than reliance on a single action. The selected approach should be technically sound, economically justified, and aligned with safety and reliability objectives. Role of inspection in risk management. Inspection as a tool for reducing uncertainty. Inspection does not directly stop damage mechanisms or prevent failures. Instead, its primary value lies in identifying, monitoring, and measuring degradation so that failure can be predicted more accurately. Effective inspection reduces uncertainty about equipment condition, which improves estimates of remaining life and probability of failure. This enhanced predictability allows organizations to plan repairs, replacements, or operational changes before a failure occurs. However, inspection only contributes to risk reduction if the data collected is analyzed correctly and acted upon in a timely manner. Poor quality data, inadequate analysis, or delayed response can negate the potential benefits of inspection activities. Inspection planning parameters, factors influencing inspection effectiveness. Several parameters influence how effectively inspection activities manage risk. Inspection frequency determines how often condition data is updated and uncertainty is reduced. Coverage defines which areas or zones of equipment are examined, allowing focus on high-risk locations. The selection of tools and techniques is critical, as different damage mechanisms require different inspection methods to achieve meaningful results. Procedures, practices, and inspector competence further affect data quality and reliability. Additionally, decisions between internal, external, and on-stream inspections must balance risk reduction against potential negative impacts, such as introducing damage during invasive inspections. Limitations of inspection: when inspection alone is insufficient. Not all damage mechanisms can be effectively managed through inspection. Some forms of degradation, such as metallurgical changes, stress corrosion cracking, or high cycle fatigue, may be difficult or impossible to detect before failure. Event-driven or rapid-onset failures may occur too quickly for periodic inspections to provide meaningful warning. In some cases, inspection activities themselves can introduce additional risk, such as moisture ingress or human error during shutdown and restart. In these situations, alternative risk management measures, including design changes, material upgrades, or operational controls, are necessary to achieve acceptable risk levels. Inspection strategy development: establishing a risk-based inspection strategy. An inspection strategy should be developed based on the results of a risk assessment and aligned with overall integrity management objectives. Key considerations include risk ranking, dominant risk drivers, equipment history, inspection results, and remaining life. The chosen inspection techniques must be capable of detecting the relevant damage mechanisms with sufficient sensitivity. The degree of risk reduction achievable depends on failure mode, deterioration rate, inspection scope, and inspection frequency. Documenting the inspection strategy ensures consistency, traceability, and continuous improvement. Managing inspection costs: optimizing resources using RBI. Risk-based inspection enables more effective management of inspection costs by directing resources to higher-risk equipment and reducing effort where inspection adds little value. By identifying opportunities for non-intrusive, on-stream inspection, organizations can reduce downtime, avoid unnecessary internal inspections, and improve unit availability. Cost optimization should never compromise equipment integrity. Instead, the goal is to achieve the greatest risk reduction per unit of inspection effort while maintaining safety and reliability. Assessing inspection results: using inspection data to drive decisions. Inspection results are essential for determining fitness for service and updating RBI assessments. Data on damage mechanisms, deterioration rates, and remaining life informs future inspection planning and validates risk models. Inspection findings may also trigger the need for repair or replacement, requiring a documented risk mitigation plan that defines scope, methods, quality requirements, and completion timelines. Timely interpretation and response to inspection data are critical to realizing risk management benefits. Keys to successful risk management: critical success factors. Successful risk management with inspection activities depends on several key factors. Inspection plans must be directly based on risk assessment results and address credible damage mechanisms. Objectives should be clearly defined, and inspection planning should follow a structured process. Appropriate techniques, frequencies, and coverage must be selected, and inspectors must be properly qualified. Finally, organizations must ensure that mitigation actions based on inspection findings are implemented promptly and that sufficient resources are available to sustain the risk-based approach over time.